This is another thing that you did in grade 10. So you've seen it before. You probably don't remember it. Most people don't. But once you've seen it in action, it might start coming back to you a little bit. And again, because you've seen it once and you're going to be seeing it for the second time around, if it didn't stick the first time, hopefully this time it does. The one thing that's really nice about this, it's related to factoring, but it's different in a special way. It is formulaic in such a way that you don't even have to understand what you're doing. If you just memorize the steps and use a calculator, you could still do this whole thing. Like you could teach a monkey to do this, or like a 5-year-old. Anybody who can write numbers and push buttons on a calculator could figure this out. Now, I don't recommend that. It's better if you understand what you're doing at least a little bit, but you can. It's a very straightforward algorithm. Whereas factoring, you got to come up with those numbers that make it work. Like you have to figure them out. This isn't like that. Okay, there's actually a strict set of instructions that you can follow that we'll get to in a moment. Before we get there, we are going to remember what it means to factor and expand and apply it in this special case. So, how do I expand this? Remember, it is not why would somebody think it is x squared plus 16?
They just square the numbers over there.
That's like distributive property. You just squared each part. That's not how it works. Okay? And your teacher always makes a big deal out of this because that's a common mistake. So we hope that if we point it out and make a big enough deal that you'll remember. What does it mean? It means x plus 4 times itself, and now hopefully we recognize this as a binomial expansion. X times x is x squared, x times 4 is 4x, 4 times x is 4x, 4 times 4 is 16. Then what can I do? Collect like terms, and because it's in that same pattern that we're used to, that we've talked about before, it's the two middle terms that add up together. What's special about this one is those two middle terms not only are like terms, but they're the same. Why are they the same? They were both 4 times x, because we did x plus 4 times itself. Will that always happen when you're squaring a binomial? Yeah. That, right? Because it's going to be something times itself. So it would be 5x and 5x, or 6x and 6x, or negative 7x and negative 7x. Like they could be negative, but they'll always be the same. Okay, so that's an important pattern. And in fact, this is another formula that maybe in grade 10 your teacher did, but you don't really have to memorize it. But it is one that if you do enough math, you memorize that this is always double that, because 4 plus 4, or 4 times 2 is 8. And this is always like 4 squared, 4 times itself, 4 times 4. And so there is a pattern there. This is a simple trinomial. Two numbers that multiply to 9 and add to 6. What are they?
3.
And? 3 and 3. So I do x plus 3 times x plus 3, which is, I could rewrite that as what?
X plus 3 squared.
X plus 3 all squared. Very nice. So it was the opposite of that first one we did. Take a look at the relationship. What's half of 6? 6 divided by 2 is 3. What's the square root of 9? 3. They're the same. That's called a perfect square trinomial. And everything we do moving forward in completing the square has to do with that concept of a perfect square trinomial. You don't have to remember it by name. You don't even really have to understand that that's what's happening, that we're factoring here. Because the way we're going to do it is a set of steps, like I told you, that you just follow the steps. But that concept of having a perfect square trinomial that you can write as a binomial squared, x plus 3 squared, x plus 4 squared, x minus 9 squared is fundamental to completing the square. It's all based on that. But again, my guess is if you practice a little bit of this over the weekend, you won't even be thinking about that. You'll just thinking about how you write it the right way. Okay? Any questions so far? Yeah.
It's going to be graphing parabolas and this on the test on Tuesday, right?
This, I don't think is on the quiz. I'll double check, but I don't think it's completing the square. I think it's just graphing. They are related though, which is interesting that you say that because I was about to say how they're related. What does that look like? Doesn't that look like this part? Right? It's that squared part in transformation form of a quadratic is always a binomial squared. So that's where we're taking advantage of this concept so that we can take something that's not in transformation form and put it in transformation form. That's where this is going. Before we get there, we're going to play a little game where I give you the first two parts of the trinomial. You come up with the third part to make it a perfect square trinomial. So what would C have to be so that this was a perfect square trinomial? Well, hold on. The relationship is half of this and the square root of that have to be the same. Two numbers add to this and multiply to this. What number added to itself gives you 12? Emerson? 6. And off to the side, I'm going to do this. In other words, 12 divided by 2 gives me 6. Then my C value is 6 squared, which is 36. Find the factor, write the trinomial, then write it in factored form. What goes in the bracket? I haven't really talked about this part yet, but x plus 6. 6 plus 6 is 12. 6 times 6 is 36. If I expanded that, I'd get back this, x squared plus 12x plus 36. Two numbers that add to 12 and multiply to 36. 6 times 6 is 36. 6 plus 6 is 12. Does that make sense? What's half of 10? 5. What's 5 squared? 25. You found it. See how easy it is? I'm going to show you something else, so I want you to write this down. C equals. This is where you don't even have to understand, but now you have to memorize, which is not ideal. It can be hard to memorize things when you don't really understand what they mean. Negative 10 squared. You don't really have to worry about the negative, but I'm going to put it in for consistency. Negative 10 divided by 2 squared. What's negative 10 divided by 2? Negative 5. What's negative 5 squared? Positive 25. So my C is 25. Plus 25. By the way, it's always plus, because when you square it, it'll always be positive. And in factored form, turn.
Put the 5 in bracket.
The 5 goes in the bracket. What kind of 5? Negative 5. So it is that negative 5. The sign matters. It always matches the sign of that x term. It will always. Okay? So that matters, and that will matter for when we complete the square. You don't have to memorize this part because you can kind of ignore the sign here and just remember that it matches that. Taryn, did you have a question?
Oh, I was just gonna say, isn't it always the answer of like C equals negative 10 divided by 2 squared, as an example? Isn't it always the middle number of the answer at the top?
Yeah.
That you put inside?
Yeah, it's always like the middle step. That's what you
I
mean,
remember
right?
that from last year.
Very good, yeah. So you divide by 2, stop. That's the number that goes in the brackets. But then you square it, that's the number that you get on the outside. And we need the number on the outside too to finish the process. So we do need the 5 and the 25. We need them both, okay? But it's that middle step that gives you the number in the bracket. And if you included the negative here, you would still have the negative there, and that negative goes in the bracket as well. Do you think you can do this one on your own? I'll help you. C equals something divided by 2 squared. What's that something? Do it. Yeah, good, but do it. So what's the number that goes there? Mackenzie, you already told me it's 16. What's 16 divided by 2? Somebody else. 8. What's 8 squared? 64. So C is 64. X squared plus 16x, that comes from here, plus 64. What goes in the bracket? Emerson? X plus 8. Not too bad, right? It's not bad. This is only one of the steps of completing the square, but it's an important one. Okay, one more, give it a try. How many people are done? Awesome. So x minus 17 all squared, 289 was the C value. Might need your calculator for that one. Might not know what 17 squared is without using your calculator. That's going to be a common thing. Sometimes the numbers are less friendly. They're bigger, or even decimals when we get into applications. So different things can happen. All right, so we are moving on to the back of the page and to where we actually put it all together and complete the square. The ones we're going to do today are a little bit easier. So the way I've written it out here, there's 7 steps. You could write it in different ways. There's about 7 steps. A lot of the steps are really short, so that looks long. It's not long. Once you get good at this, it's probably 2, max 3 steps of writing. Okay, but you do want to learn the different steps, because I've had students who refuse to do it the way that I show them. They try to do it their own way, and 100% of the time they're wrong. So I don't know why they change it and then they're wrong every time and they continue to do it that way out of stubbornness or whatever. But trust me, I'm going to show you the most efficient way of doing it, the safest way of writing it. And if you try to shorten it further, danger is coming. So, why are the ones we're doing today easier? Because A is 1, A is the coefficient out here. When that's a number like 2 or 3 or -4, there's a couple of extra steps. Okay, but for this, we're going to just do the simple ones. As I go through this, I am going to refer to the steps, but they're wordy, so you might not fully understand what it is they're saying until we've been through a few. Some people like written out in words instructions. So after we've done a few and you're starting to get the hang of it, you might go back and kind of read the different steps and have them make more sense. Or if you go home and do your homework and you're doing it Sunday afternoon, you kind of forget what to do. Maybe reading through those steps will help jog your memory. But if you do enough of these, if you do the practice tonight or sometime over the weekend, you'll remember this and not have to really memorize the steps. You'll probably just remember what to do. So step number 1, make sure your quadratic is in the correct form. There might be times where it's not written properly. Is it? Yes. It's already in the correct form. It's in expanded form, fully simplified. There's no like terms that I can put together, no brackets or anything like that. So for the first one, step 1 is done. Group the x terms together, x squared and x using brackets. For the first couple of times we do this, I'm going to show extra steps. This is for learning. Trust me, you want to do it right now, but then eventually you don't have to do this as a separate step. So I'm going to do that. All I did was put brackets around those. You could even just do it in the question, right? You could just do that if you wanted to. Done. See, I told you these steps are short. Step 3, common factor the coefficient of the x squared term out of both terms. This is what we don't have to do today because A is 1, so we don't have to do that step. We're skipping it. That makes these ones a little bit easier. Find the value that turns what is inside your brackets into a perfect square trinomial. This is find C from the last example. Find that C. Who remembers, or maybe this is a better question, who already forgot how to do it? It's only been like 2.5 minutes. Who remembers how to do it? Mohammed, do you want to do it for me? What do you write?
So it's C equals
Yep.
12x.
Yep, keep going.
12x divided by 2,
Good.
and then brackets, and then squared.
Beautiful. I dropped the X. You don't need the X. It wouldn't be wrong because I'm not marking that part anyway. But if I was doing this off to the side, I'd leave the X out. Fantastic. And now you just figure it out. So 12 divided by 2 is 6. In fact, we already did this one. 6 squared is 36. Fantastic. Great job. Find C. So that's always part of the procedure for completing the square. Done. Now what do we do with it? This is weird. Add and subtract this value inside the brackets. Why would I do that? Plus 36 minus 36. Writing the whole thing out every time. Why would I add it and subtract it? Why don't I just do the one that I need? Is what was said. That's the graph. That's not a very good look at the graph, but this is a parabola. That's a graph that we just did. Okay. And if I take that graph and I add 36, I change it. That's a different graph. Well, you can't just change the graph. That changes the question. If the question is about somebody threw a ball, where does it hit the ground, and you change the graph, you're changing where it hits the ground. You can't do that. But if I add 36 and subtract 36, I don't change it. It doesn't move. It's the same graph. The equation looks different, but I haven't actually changed the graph. I haven't changed the function. It's the same function. So it's going to give me all the same answers. Turns out that's really important. And you might say, well, if it doesn't change anything, why are we doing it? Because we're just rewriting it in a form that's more useful. But effectively what you're doing here is adding 0, so you're not changing it. Add and subtract, so we don't change the quadratic since we're adding 0. It even says it right there. We're done 5 steps. 6, remove the negative from the brackets, apply distributive property if necessary. That part we don't have to do again, which makes it more work because we don't have an a value up front. So we don't have to worry about that. That's Monday. Monday we're going to learn what to do when you have an extra number. Pull the negative outside. It's always the negative 1. Always, always, always the negative 1 that you pull out. Factor your perfect square trinomial that we created. I'm going to factor that like we did in the previous example and add those constants together. So how do I write this in factored form? Emerson?
X plus 6 squared.
Remember, it's that number again, but x plus that squared. Negative 36 minus 3 is negative 39. Now it's in transformation form. Now I know the vertex. It's negative 6, negative 39. Now I know the direction of opening. It opens up, so it has a minimum of negative 39. And those are really useful things for solving word problems or real life problems with quadratics. So that was 1, 2, 3, 4 steps. We can easily cut it down to 3. You could maybe even get away with 2, but I would be careful. And when we add in what we're doing Monday, it makes it a little bit harder. It's worthwhile not trying to rush through it. So for now, you don't want to rush too much. Let's wait till this is done. And then okay. All right, the next ones we'll go a little bit more quickly. Isolate the x squared and the 4x minus 4x. That step you don't really have to write. I'm not going to write it again. What's my C? If you can't answer this question, even if you were following it on the previous page and kind of getting it, but if you can't answer this question, that's a problem. This is a fundamental, important part of this procedure. How do you find it and what is it? What is it?
Is it minus?
Huh?
Minus 4?
It's not negative 4 though.
Oh, positive.
But you added and subtracted, so it's kind of both. But the C value is always positive, so half of 4 is 2. 2 squared is 4. So it is 4. Add it and subtract it. One of the terrible examples, because everything's 4 and you can't really follow why it is. You know what I mean? Like, oh, it's just the same as the middle term. No, no, no. That's a fluke. Move the negative 1 outside. What's that?
Negative 4, not negative 1.
Oh, yeah. The negative 1 is what I meant. Like the negative 1, the negative number. That's what I meant. But you're right. That was a bad way of saying it because it sounds like negative 1. Some people would say, why can't I just write that one outside the brackets on that step? Well, because you have to do something to it when it's the harder ones that we're going to do Monday. So for now, I really think it's a good idea to be in the habit of writing them both inside the bracket and then taking the negative 1 out. But you can certainly skip that first step. Okay, how do I factor this? Negative 4 plus 1 is negative 3. Somebody else, Emerson's done it for us every time. What goes in the brackets? Dan, do you know? What goes in the brackets? Remember, it was x plus 6 up here. Think about it. Zainab, do you know? X minus 2. Why is it 2? Yeah, it's half of 4, right? It's the 2 that was that thing, half of 4. Same sign, or square root of the c value, however you want to think about it, it's both. So in this case, it's 2. What's my vertex? Positive 2, negative 3, h and k. It opens up, so again, it has a min of negative 3. Notice how I'm writing that every time? I think the homework says to do that every time. Because when we get to applications, that's what you have to do. Try this one on your own. I'm going to skip that step. I'm going to do this. I'm going to put those in brackets and just leave some space to add and subtract what I need, instead of writing that extra step where we didn't really do anything. Oh, yeah, go ahead.
Why was it the vertex?
So I believe in the homework it says to do that. And if on a test, if it doesn't say to do that in the instructions, no. On a test, if it says to do that, yes. When we get into word problems, that's the whole point, is recognizing that it has a maximum or a minimum and where it is. So it's good to get used to it, but it depends on the instructions. I got x plus 4 all squared minus 6. Is that what you got? If you did, fantastic. It only took you 3 examples to be able to do this, right? That's really good. Okay? Because it's a pretty big algorithm, like big enough, right? Compared to a lot of stuff that we've done up to this point in algebra. But it's a neat one because it works every single time. No matter what your numbers are, even if you end up with fractions, it still works. Can be harder to do in your head, but your calculator can do the hard part for you. So it's a neat algorithm in that it always works. You can always make it happen. Any questions? We're going to do one more. I'm going to ask you to do it yourself again. So you're going to take that, complete the square, put it in transformation form. Then you're going to find the vertex. And it's not going to have a stretch of compression because we don't have that part. That's the extra part for Monday. So it'll be a simple one to graph. But then try to sketch it. Okay, see if you can. And when you're done that, you can move on to the practice. So I'm going to let you try that on your own. I'm going to walk around and make sure you're doing it and just check to see how you're doing in case you have questions. And then I'll put the answer up in a little bit. Okay. Okay, there's the solution with the graph. Don't get lazy, actually do it. This is where the practice comes in, and tying it to the graph, which you don't have to do in the homework today, but eventually that's where this is going. Okay, so once again, once we put it in transformation form, we can get the vertex, which is what we've been talking about for the last little bit, but guess what? We're gonna keep practicing it for the next few days, so if you weren't quite there, if you weren't getting the signs right, you still got some time. But how are you gonna make sure, if you haven't gotten it yet, that you're going to get it? Do the practice and check your answers. Look for mistakes. If you wrote positive and it's negative, or if you wrote negative and it's positive, ask yourself why. That's where the learning happens. Okay.